highest education mode. So learning highest education, taking the highest ladder and then working on it is the most important thing for us all. And I appreciate you all learning all these classes. Right? So let's see what we are going to do.
My voice disturbance వస్తుంది.
Can you hear? Voice ఇంకా
Disturbance ఉంది, ma'am.
Ask
everyone just stop talking. Let's ma'am to take class. Guys, please, everyone just quiet. Only ma'am can talk. After the class, if you have any doubt, then you speak.
That is more
until ma'am can speak, ma'am. Explain, ma'am.
Yes, ma'am. So
yes, ma'am.
So here, in the first one, we are going to learn computers in general or introduction to computers. Let's see what is there in that. So what is a computer? All of us know that it is an electronic device. We are able to receive the information, then process the information, and then get whatever we want as per the instructions that are given. We are able to get the output from the computers, information that are given. We will be able to get the kind of output whatever way we want. So just computer is a programmed device. It's just a electronic device with set of informations to perform specific tasks and generate results at a high level. So calculators are there, but calculators can do a little only, very few things. Computers can do immense number of data processing or immense number of calculations or analyze the data, understand the data, process the data, and give you the needed outputs. So computer is an electronic machine. So all of you can remember. The computer's concept did not come now in 2000 and all. It is actually started in the year 1801. That was when people started using the computers. When you see automatically there is a wave fabric design. Early computers would use bunch of cards. So they have this kind of automatic way of doing it. After Industrial Revolution, then definitely there were people who were working on these things. And you all know Charles Babbage. He's an English mathematician. He is called the father of computers. So he was the first one who found out stream-driven calculating machine. Actually, it was not called as computer in those days. It was called steam-driven calculating machine. So which computes tables of numbers, and it found out the project is very good. But later on, slowly, it got failed. Then in 1890, later on, after 1800s, because there was a lot of people ruling the other countries and all, this got break. Again, in 1936, Alan Turing started this process once again. And he has, if you see the apple, the cut bite of the apple, that was given by Alan Turing. That's what people say. But there is no relation between those things. Still, he was the first person to give the computing table, a machine which is computable. And I'll show you how Alan Turing computers were there in those days. So central concept is the modern computer was based on his ideas. Please don't do all these annotations. Then comes, we have 1937 to 1942. There was a lot of processes that went on, and then people started building the first set of computers, basic computers. Then we have the designed computers, whereas electronic numerical calculators. So this was ENIAC we call. It was launched in the year 1943. And later on, slowly, Bell Laboratories have invented and replaced the vacuum tubes. Inside the big systems, computer systems, when you see, they were very, very big. Like when we studied in our college days, maybe in 1985, those days, it was the very beginning of the computers in India. And of course, maybe 1960s, it was there in the US and the other countries. Those days, when we used to write the programs, we used to write the handwritten program, go to the university, give the handwritten program, they will feed into the computer. One big room was the computer. And in that, the small, the program what we wrote, that was feeded into the computer, and computer gives the output, whether it is right or not. any errors are there or not. It will check on that. After checking the errors, we should come back and then rewrite the program again and submit. This was the stage where we used to learn the computers. From there till today, if you see IBM or other Dell computers or Dell laboratories, all these people have
Excuse
done
me,
a
ma'am.
lot of
Hello, ma'am.
research on the
Excuse me.
computers and then
I
brought
have a
very
one doubt, ma'am.
innovations.
Hello, ma'am.
Hello, yes.
Yes, ma'am. I have a one doubt. What is vacuum tubes, ma'am?
These are the ones where you inside big capacitors and all will be there. No, they ensure that the signals will flow properly in the if you see in the desktop, I mean CPUs are big systems. Now we don't have all those things in our
Yes,
laptops
ma'am.
or in our systems. We
Yes.
don't have all
Okay.
those things. Right?
Okay.
Yes,
Nowadays
ma'am.
is a storage capacity. That's like a vacuum tube.
No.
Nowadays we
It's
call
not
the
the
storage
vacuum
capacity.
tubes are not for storage capacity. To get the better
Okay.
signals.
Instant storage memory.
No.
This is how the computers look. Big system.
We can't hear you, ma'am.
You knew it. And Charles Babbage, you have the era computers called analytical engine. This is the kind of analytical engine we had. This kind of tubes were used, and they had.
Ma'am, we cannot hear you, ma'am.
Yeah, please don't.
Ma'am, your voice is not audible.
If you don't talk, you can hear me.
Yes,
Yeah,
ma'am.
Okay.
yes, ma'am.
Everyone just quiet. Let's ma'am take a class.
Yeah. If you are all quiet, then we can do it. Yeah. 8E dual. Who is this Redmi? Any doubts you have? Okay, your doubts will be cleared. Last half an hour, I'll give you the doubts session. That time we can work on it. So Charles Babbage era computer, that is the this thing. Then electric tabulating systems that was given by Hollerith, and this was the Alan Turing, what he gave, his analytical machines. I think you can see how the systems are such a huge, big systems, and so many connections, so many tubes, so many processing systems, etc. But later on, have been very made into slim sized ones. Now today we can do process all those things on our mobiles also, right? So we will learn all those things in these modules. Now, what is the generations of computers from where to where we have come? So 1936 to generally we take the from 1800s to 1900s, we don't take them into as actually the computer processing that has happened. From 1936 onwards, we take the first generation computers where vacuum tubes as processor and magnetic drum as storage. Inside that old systems, when you see, you have all these things. And they were mainly using the binary language 0 and 1. They never used to understand, computers did not used to understand the English language. It was not there. Everything, whatever we write, no, that is converted into 0 and 1. Binary language we call. Each and every number, each and every language, everything is converted into binary values. So, and punched cards used as IO cards, input and output cards we call, input and output storage operations. Then we have these systems used to consume high power consumption and generates very heat. Those days, no, they compulsory used to have, wanted to have the, what do you call, it should be the AC rooms only. Otherwise computers don't work. It was like that in those 1900s and 1956, 1960s. Then too expensive to use, only perform straightforward mathematical operations. Those days, computers did not use, was not processing all the other data analysis and all. They used to only process the mathematical calculations. Any type of mathematical calculations was able to do, the computers were able to work on it. Then they used to occupy that whole room, 10 by 10, that big rooms they used to occupy, huge machines. And whatever is the input devices you have, all those input devices are also, now we have the mouse or the other things, mouse pads and all. It was very difficult difficult those days and very slow. All the systems, you enter it, all the data it will take into from one end to another end to another end, and then finally it used to give you the output. That was very lethargic, very long time it used to conduct, and all the storage operations. Of course, storage was also, today we have gigabytes, terabytes, and petabytes, correct? But those days it was very small storage systems. Then we have all these are the examples. Second, to 19 and Honeywell have produced this kind of second generation computers. Slowly what they did is this vacuum tubes and the other things they eliminated, and trying to put the semiconductors and other easily processing systems, so that that will be easy to process the data and then give you the analytical answers. Then magnetic core is used as primary, and magnetic tape. You have seen your tape recorders, magnetic tape was there. Like that, magnetic tape were there, floppy disks were there. So assembly language we used same input and output device. That consumption, these had low power consumption, and they used to not generate huge quantities of it, but it is comparatively normal, a little reduced. Whatever was they found computer, a little. Coming to the third generation, we have more better semiconductors and quartz devices, so that these generate less amount of heat and have a very long backup this thing they used to give. Then RAM and ROM were introduced as primary, and magnetic disk was used as secondary. So RAM in the first, this thing they used to keep it, read access memory and ROM. And these were the primary ones. And we have at the back end magnetic disk, CD disks, floppy disk, all the other magnetic disks were used inside the system itself, hard disks that were there. Later on, the external devices have come. All those were the first languages that were given in the very good old days of 1960s, 1970s, 1980s. Also, it was the same almost. Compared to first and second generations operating systems, these were less expensive and used to perform a little better mathematical, more better calculations of mathematics, scientific and business applications. Also, they used to give space operations. They were used in the space operations also. Then we have idea,
Ma'am, your voice is not coming.
Then we had the keyboard, the LCD monitors, mouse, laser, inkjet, line printers. All these things started coming in. One after the other devices used to get added to the basic system of computers. Then this has the multi-programming. You can have multiple windows open. You can work on different things, and then LCD monitors, additional devices were there. Multitasking was given, and systems became more reliable and very accurate and efficient. And there is one more important concept what we need to see is battery backup. Battery power consumption was made more durable and less expensive, right? So then coming to this computer, one second. In the fifth generation computer, the technology has improved very much till 2000, from up to 2010 or 2010 onwards. And today we are using very sleek systems. Even if you have the anything you want to ask, you can ask me in the last.
Ma'am, your voice is not clear.
So we had more sleek systems we have, and these are giving more backup, and then multi-core parallel computer structures and parallel programming is happening. Today we can do n number of things on the computers. You can access, you can see the movies, you can see videos. This was not possible in the very good old days. You can connect to anywhere across the globe. You can talk, you can see the things, whatever you want. So there are beautiful software or softwares like good, very operating
Guys,
systems like
transcript is
Windows or
coming
Intel or other
there.
things.
Look at there. Everyone look at there. Transcript also coming. Don't
All
disturb,
these things, new
ma'am.
things have come so that it becomes very easy for us to store the data as well as access the data and read the data whenever we want. Okay. So next
To
one,
your
have this thing assignment given. Okay, I'll give you the assignment later on. Then classification of computers. Classification of computers, they are classified into three categories. One is based on the functionality. Suppose a scientist is working, then he, yeah, please don't do Dinesh all this. So according to if whoever is working, a doctor is working or a scientist is working or a manufacturer is working, banking sector people are working, based on their functionality, based on their requirement, the computers are give you the kind of output. Then according to capability, how you want, what, for what purpose you are using. So what capability, all this. So according to functionality, computers based on the hardware. One is the digital computers. This is a computer which converts into 0 and 1. So these computers generally use the desktop, laptop, tablets, mobiles. All these are called the digital computers. Today we use the digitalization into n number of applications. Right? Then comes the analog. So analog computers, I'll say computers is plenty of times they use the sine wave curves, and then here they basically are used for manufacturing devices. Suppose if you see in the petrol pumps, in the telecommunications, in the ventilators or the electric meters, gas meters, thermometers or speedometers, all these are also a computer, but they are used for a particular purpose and they give the numbers, output as the numbers. So analog computers we call. Then with digital and analog together, they brought up the new kinds of technology, which we call as hybrid computers. And hybrid computers, they have the modem converts the analog to digital and vice versa. The analog to digital computers, they'll convert, digital computer to analog computer. So this is what is the hybrid. These are what we use in our daily. Nothing but they convert the data, whatever you are giving, into a 0 and 1 format, binary formats, and then work on it. Backend analog tab and the other things. Analog computers generally we don't use for the household purposes, but in the big manufacturing units, or you call in the what do you call, in the hospitals, on the manufacturing units, in the scientists, everywhere analog computers will be used. Then the next one, according to the capability, what are the capabilities? Your desktops. What we use here is the desktop. Today what I'm speaking is the laptop and desktop. These are the things what we have. So I devices. Secondly, separately connected. We have the CPU separate, and then we have the printer separate. We have the mouse separate. All these things you can detach, or if you want, you can add them and then work on that. Single board computers, all the ports integrated in one board. See, our this thing, everything is into one system, one part inside only built. Then that is called the single board computers, single unit computers, all in one. Our PCs are nothing but the single unit systems in which you have the mouse pad, you have the keyboard, you have the display, you have everything inside the system itself. You have the audio system. In the good old days, audio system is separate. Video, you have to log in and then get it. Video connection, webcam, all that you have to separately connect it. Here it is now in the latest technologies, we don't need to connect all those things, external device. They're all coming as built-in. Then net tops, mini single unit system with Wi-Fi and Bluetooth. Inside that, Wi-Fi and Bluetooth also will be provided so that if you want to connect to, suppose you want
Voice is not clear, ma'am.
your headphones. Headphones is without any connection, wireless ones, Bluetooth connections. So all those are built in and you can use them easily. Then microcomputers or mobile computers. In your mobiles also this is used, actually very small tab like things, laptops, mobiles, PCs, all these things are nothing but the microcomputers, or we can call them as mobile computers. You have the notebooks, you have the ultrabook, Chromebook, all these are this palm size ones, right? So it is easy for you to access, and inside that only you have the audio systems, video systems, you have the keyboard, you have everything inside that. That makes it very simple and easy for you to carry anywhere, wherever you want, and use them as a smartphone or use them as a computer. Then we have wearable gadgets. Nowadays, wearable gadgets, these are some types of wearable gadgets. These also acts as a computers only. This is one computer system where from here you can connect. If you put that watch, smartwatch, I hope all of you have seen the smartwatches. So if you once you wear the smartwatch, you can access the computer, what mails have come, to whom you have to talk, or you can receive the telephones, you can see the WhatsApp messages, you can see everything on the watch itself, what kind of thing, any kind of things, whatever you want. It has both all the information it acts actually exactly like a computer only. And the head mounted glass, this also will be used for devices only. And these are the some of the wearable gadgets. So in the wearable gadgets, smartwatches, they come with the Wi-Fi, they come with the Bluetooth connection and control smartphones and other devices for that. Then you can say Apple Watch, Samsung Gear, all those things. Head-mounted devices, head-mounted devices, heads-up display we call, are worn or attached to the head and uses the transparent glass so that you can happily see your computer screen. You might have seen in the movies and all, English movies and all, that they just swipe and then see those things. Then smart wear, smart shoes or smart clothes, all those things are there.
Ma'am, your voice is not clear.
Then mini computers or workstations, all our what we use at home are nothing but the mini computers. You can see the desktop, laptop, notebook, hybrid computer or tablet, smartphone. All these are nothing but the mini computers we call. Then we have mainframes. This is called IBM mainframes, and they have huge, very, very big, large amount of data they used to take, and they have very low processing capability, but huge number of users are to be connected concurrently via terminals or PCs. Suppose whatever information, think about WhatsApp servers, how they are connected, how much of data, where do they store the data, how do they process the data, who has sent what message to whom, all those, everything will be done with the help of the mainframes. Terabytes and magnetic tapes and disks. So gigabytes of RAM will be used for these computers. Then we have servers. All the data, whatever we are generated, all the data that is generated is somewhere it has to get stored or processed somewhere. So where is it processed? In the servers, or where is it stored? In the servers. Large machines which are designed to provide services, functionality and resources. This part is very important to the client machines and client server network model we call. So here, large machines, big machines will be there here like this, or like this huge machines. And these machines, what do? They provide services to us. Your Ola or Uber or WhatsApp, all these things, all these platform businesses use this kind of machines. The functionality and the resource of the client machine. You are logging in and you want to access where are the cabs available in your vicinity. So for all those things, this server based will be working. Then we have supercomputers will be much very bigger ones. Contains powerful multiple multi-core processes in one machine. All those things, everything will be put into one this thing, and they have huge speed and accuracy, very fast, quickly, within no time they can conduct, and then the process will be very fast, and you get back the results at the millions of instructions, MIPS. These kind of computers on trillions instructions second.
Again, your voice is
And
not coming
or
in.
millions of instructions. The above computers work on millions of computers per second. So far discussed. So the speed of the supercomputers is still more. Whatever previous ones, what I told as very small, whereas we have petafloating point operations per second. Peta is the highest speed. So that kind of operations will be there. Then the power of supercomputers is nowadays are essentially in predicting natural calamities. This is more important. Where are the supercomputers used? Suppose anywhere earthquakes are coming, I have to get the information quickly, and then that information has to be sent to the local areas where evacuation should happen. Right? Earthquakes or calamities or lava or anything that is happening, or in the defense mechanisms. Suppose some country is putting the missiles, or some country is working on atomic research concepts or anything. So for all those things, defense systems, they use this kind of supercomputers. Also in the space launching, space satellite launching and all, they use the supercomputers, because what Mars, with what speed it is going, you have to launch your satellite in that speed, in that particular orbit. It's not easy. I hope all of you have seen the Mangalyaan movie. In the movie, what we see is very little, but originally it will be much more faster, much more quicker. The processing will be very fast. Then we have timeline of major supercomputers in the world. 2008, runner we call IBM. Speed is 1.105 PF petaflop bytes. Then we have Jaguar, which is the Crane, USA. Then Japan.
Ma'am, I'm not getting your voice.
2.56, more than.
Ma'am, we are not able to your voice, ma'am.
I'm using maximum of my capacity, right? Hello, can you hear Ravi Kumar?
Yes, ma'am.
Okay, so we have whoever are unable to hear, please check for the network at your place here. Once, please try. So we have
network is good, ma'am.
if you see carefully, the Japan and China are equally having that kind of supercomputers. If you see, China has 33, China is 93. I will show you one scale here. 93, National Supercomputer Center. Working, it is in China. 93 PF LOPS. This is the huge, faster supercomputer till today, right? Then we have China again 30 PF LOP. Then US stands at 17, etc. All these are the hierarchical order I gave you. 10 top 10 supercomputers. We have embedded systems. And the embedded systems means which are inside the systems itself. So, for example, if you see your set-top box, each one of us in the house, we have the set-top box. These set-top box are connected to your local vendor, from local vendor to the digital platforms, whoever is giving you the access to your antennas, or for you to see the television channels. So how much usage you have done, how many hours you have done, from what time to what, from what day to what date, all that information, that means back end, this embedded systems will be working. So your the set-top boxes, anti-lock braking systems, or players, ATMs, cameras.
Ma'am, in between explanation, sometimes your voice is stucking. That's why we can't understand anything, ma'am. Once you check, we can't understanding properly. In between explanation, your voice is stucking.
Yes, ma'am.
Which one you didn't understand? I'll repeat.
Embedded system, ma'am. Again, you can
I'm
please explain us.
that only. I'm explaining.
Yes,
that
ma'am,
only.
you are explaining. We are saying that you are explaining, but we can't hear you. That's why something we understand and something not understand. In between explanation, your voice is stucking. That's why we can't understand some points. Can't understand or understand some points. Okay, ma'am? Your voice is stucking in between. You is speaking, but we can't listen you properly, ma'am.
Please check the network from your end also.
Yeah, ma'am, it's
Sir,
okay.
I'm asking, Mr. Ravi Kumar is here, so I'm asking him, can you hear continuously, or are you getting the break in the voice?
Little bit, ma'am. Sometimes drop your voice in middle. Mute.
Because I'm very
explanation
close
is
to the
stucking, ma'am. That's why we
Okay,
can't
one second. Okay, I'll try.
Okay.
I'll try something.
Okay, ma'am. Okay. Okay.
Oh, just hold on. I'll attach to the earphone so that it will be easy for you to. One second.
Hello, Mr. Ravi Kumar. Can you mute everyone? Actually, you have the administration. This one. Can you do the mute to everyone?
Yes, everyone, please mute your mute. Everyone, all students, please mute. Let's ma'am explain. Everyone, just mute. If you have any
Mute your.
Okay, close it. It will be still.
If you have any doubt, ma'am, Sina, they gave the time. Then you
Please
clear your
mute your
doubts.
mobile
Everyone
phones.
in between class, nobody talk. Please, only ma'am can explain. Okay, please, everyone mute.
Just hold on. I understand your problem. When you hello.
Yes. All students, all friends, please mute your video. Let's ma'am only explain us. Mute your video, also voice. Okay.
Please. Just hold on. I'll do one thing. I'll stop sharing. I'll mute all so that it will be easy. Because everybody is on this thing. That's where it's getting distracted. Just hold on. One second. Ravi Kumar, can I mute all?
Ma'am, I think you can mute all, and if anybody has question, they can raise the hand and you can answer those questions. You can take those questions. Once they raise the hand, you can answer the question. Otherwise, you can mute everybody.
Unmute them. No. There is no way to mute all.
Ma'am, host can mute all the participants. I think you can request host to mute all the students, and everybody should be on mute.
Yeah,
if somebody has question, they can raise the hand, and you can address that question.
Yes, I have muted. Now I hope it will be easy for you all to Yes. Now, I think all of you can see that embedded systems we have. Embedded system which combines the microprocessor software and with some electronics or electrical or mechanical hardware to perform specific function. Here, what we need to understand is it can connect to electronics or electrical or mechanical. Any of those things will be done inside the system itself. For example, if you are using the anti-lock braking systems, this is a mechanical part of it. In the mechanical part of it, it works on that. At the same time, backend in your Tesla cars and all other advanced versions, you have the anti-lock braking systems. By default, it will get this thing. And the same manner, you have your ATMs. In the ATMs, if you go wrong anywhere, your PIN number or your ID or other details, whatever you are feeding into the system, if that is not appropriate, automatically it blocks your card. So that is what ATMs are working. And you have digital cameras. Most of the places we use the digital cameras, and needed information will be taken and they collect proper appropriate information. For example, in the railway stations, in the other places where digital cameras are very, very important. Then drones. They also use the computers, embedded systems only. Somebody else is operating, but the drone is flying, and then it checks on whatever is the necessary ones. Your printer and internet dongles, all these things are the embedded systems we call. They have both electrical, electronics, and mechanical hardware. They remember, drones has some specific purpose. Same manner, you have your ATMs has one specific purpose. Here we need to understand, whatever purpose is there, that instrument will work only for that specific thing. Inside, they have the operations of the computers only, right? Then we have, these are all embedded systems examples. You have some vehicles, this embedded system, anti-lock. Wherever you are going, if you are carrying any threats or anything, especially in the metros and the other anywhere, wherever metal detectors, motion sensors will be there. So as you are moving, whatever you are carrying, you will be caught, and then they check on that. Manufacturing equipments, in those places, embedded systems, how much is loaded, how much is done in the truck, what is there. A simple embedded system, I can tell you, suppose if you go to the Reliance Trends or any apparel showrooms, what you find is, in the apparel systems, they keep one magnetic thing. You see that is that with that you cannot walk out of the shop. You have to ensure that that is connected. If it is there in the apparel, then you cannot walk out unless it is built. Then domestic appliances, we have set-top boxes and the other things that are working. Then audiovisual equipment, your televisions and all use the set-top appliances. Then gaming consoles. Then telecommunications, obviously telecommunications today, we all use mobiles with Wi-Fi and the other electronic systems. Then medical devices, medical people use embedded systems to a large extent for operations. Nowadays, we have the robotic operations that are happening. The surgical operations and all is nothing but the embedded systems that takes place. In that electronic, electrical, as well as the mechanical, because the doctor first understands what kind of operation, where exactly, how it has to be done, how much time it has to be done. All that is pre-fixed before the operation surgery happens, and then that will be applied. So that's how the embedded systems work. Then we have according to the purpose. So if you see, we are going through different concepts. First one is we found out that it is used as per the capability. Then we have understood that it is according to capability, different things are there. Then according to our purpose, whatever be the servers and all we are working. Then we have embedded systems. Okay, 1 second. So the next one is according to the purpose, what kind of computers can be used. They are classified into two categories. One is the general purpose computers and second one is the special purpose computers. General purpose computers is nothing but your simple computers. Right, but see, these are all in one inside the other. You can find sometimes the same thing will be there in the previous one, same thing will be here. So general purpose computers, your linguistics, application development, business administration, all the MNCs what they are using today, or customer service report, everything, whatever you are doing, all report systems, auditing systems, etc. Everywhere, wherever you are using application development, software developments, Google. Anything you talk about it, that is nothing but the general purpose computers. Whereas specific purpose computers, we have special purpose. Suppose you have the ECG machines or air traffic controls or domain specific robots. Today, robots, I just told you, they do the operations, they perform the operations. In the space exploration, all these have the special purpose. That computer has designed only to take up that kind of operations, right? Then we have the hardware. What computers have as such they are working on. Computers are defined into two categories. One can be made into two things. One is the hardware. Hardware is just like the skeleton. So a skeleton of the computer, we can say. Human body, we have the mass and the other things, whereas this is the skeleton. So computers, all the physical parts, what your input output devices or the connections, webcam or audio systems or the keyboard, mouse, all these things are the hardware. What is inside Intel core, motherboard, capacitors, these are all called the hardware parts of it. So in the hardware, we have the cabinet, we have the CPU, we have the motherboard, then monitor, hard disk, processor, RAM, VGA port. VGA port is for the visuals, this thing, graphic card. All these things are just the hardware part of it. And computers need most of the hardwares, because if the hardware, if the skeleton is not there, we cannot stand, we cannot do anything. Skeleton is important. So hardware is important. Parallel port, serial port, Ethernet. Means for you to connect to the Wi-Fi, you need Ethernet. For you to connect to the different systems, we need the serial ports. For you to connect to the audio systems and all, you need the parallel port. So sound cards, RAM chip, everything we need. So we have the software. This software is nothing but the, we can say it is the heart. Right. So all the kinds of programs, simply hardware, all different parts of the body, if they are there, parts of the body are there, but they have to be connected somewhere. So software makes this hardware work in the right manner. It connects one part to the other part to the other part. Suppose I'm using the mouse. So this mouse, what information I have to use from the keyboard to the desktop to everything. So like this software is the one which is working at the back end as an operating system. And the other things are which makes the processing, which makes the software, whatever processing you want, all those things will work in the right manner. So examples of software is nothing but your MS Office or C, C++, Linux, Android, Internet Explorer, Facebook, anything you can talk, HTML, all JavaScript, all these things Zoom is using. So all these things are nothing but your software which is working at the back end. Devices are the same. Suppose, for example, if I'm using the same thing for Zoom connection and talking to you, this is one purpose what I'm using. At the back end, suppose if I'm doing any transaction or booking a ticket, air ticket, etc., that is one transaction what I'm doing. So you can use multiple things, different softwares which are running at the back end, which makes me use for the different purposes for which we are using it. So we have the limitations of computers. What are the limitations? Of course, though computers are really very important for us in our daily life. They use a lot. They are used for a lot of things. It became part and parcel of our life. We listen to music or watch movies or do everything. In spite of that, there are certain things which makes us compulsory for us to use the computers. So despite all those things, also computers have certain limitations. What are the limitations? No matter how much you watch on the Facebook or WhatsApp or Twitter or etc., but computers have no feelings. You may have friends on the Facebook, but these friends are only till they are friends, which gives a like or comment on that, but they don't exactly give you any feelings or expression to make you feel comfortable, right? The computers cannot implement, unless and until you have the software, you cannot implement the anything, whatever you want. That means you can keep the data information, but processing of the data and analyze the data and give you the output of the data, all the things computer does, it cannot do by itself. It has to be some software that has to be there, and somebody has to process that. Somebody has to give the instructions for the computer to work on it. In the next lessons, we will be learning in a much deeper into how the computers work. So the computers cannot implement the things by themselves. Software is also there, hardware is also there. These are just like the parts of the computer. But a person who has to sit on that and then make it process, make it function, give the command to the computer, then only it will start functioning. So actually, it has no capacity to implement the ideas or using the resources. It cannot do by itself. It does not have the feelings. It does not have the capacity to implement the ideas or using the resources. Suppose a keyboard is there, a mouse is there, it cannot do by itself. You have to operate it. You have to make sure that it does connect it, and all the software at the back end, all the hardware at the back end connects and then work on it, right? Then no learning power. By itself, computer cannot learn anything. No doubt we see from 1800s to 1900 to 2000, 2020, we are millennial people, Gen X we call. So these people, we are born and brought up with the computers only, right? So, but here, one thing we need to understand, people make the computers work more better. Computers work more smarter way than us, but by themselves, computer cannot learn anything. It is we are giving the instructions. By whatever instructions we are giving, it works on that. So for example, when you are taught how to solve a problem, you can do the problem by yourself, but computer cannot do it by itself. Clear? It may if you give more number of different things, it will work, but a new environment, new situation, it won't. Today, we are having now, because this concept of no learning power, people have worked on that. Plenty of scientists have worked on that. And today we have machine learning and artificial intelligence, where we are making the computer trying to learn, looking at the patterns, looking at the way the data is there. Based on that, computers are trying to learn by themselves through artificial intelligence. Then computers cannot express anything itself. Whatever output you are giving, that is the required output given by the instructor to the computer, and then desired output only will be coming out. So if whatever we are giving the instructions, based on the instructions, what kind of output we are looking at, accordingly only the computers will be giving you the instructions. But the computer by itself, it cannot do it. Certain, you have seen the Robert cinema, right? That Rajnikant movie. So in that movie, the instructions are correct. Whatever is the right thing, he does. But ethically or civic sense, sometimes they are not right, right? So here we need to understand, computers cannot make the decisions by itself. Whatever instructions you give, just it follow and then complete the tasks. Then no self-intelligence. Today, computers is able to do a lot of impossible work. If I have, for example, when I'm teaching data analysis, in the data analysis, I have 10,000 lines or 50,000 lines or 1 lakh lines. Facebook data that is generated, we need to process that. So how do you process that huge amounts of data? It is impossible for the human being to work on that. But for the computer, it is extremely easy. It processes the data faster. It does segregates the data. It puts the things in the proper manner. But by itself, it cannot take intelligent decisions. Intelligent way, it cannot think. So this is about your first unit. What is about the general concepts of the computer. At last 10 minutes, I'll give you further questions quickly because we have to complete the portion also. For that reason, I'm rushing up. I hope all of you are able to listen clearly. Can I have any, whoever is keeping the video on, can you show your thumb? You are able to hear me? Ravi Kumar, can you hear me? Yeah, good. Thank you. Clear, right? Data is, you are able to clear. Nice. Thank you. So then we have learned in the first unit how the computers, what are the basic structures of the computer, how the computers have evolved, how they have in over a period of time, how computers have changed, and then how we are accessing the computers in the day-to-day life, right? Today, it is indispensable for us. Indispensable means without that, we cannot even think. If I want to do any transactions online, if I want to, today, I don't need to carry my purse. If I carry my mobile phone, that is more than enough. It's indirectly a computer, what I'm carrying in my hand, right? I can do the transactions. I can pay anywhere. I can see the movies. I can watch. I can talk. I can read. I can understand. I can access the news. Everything I can do only through computers. That is the mobile device what we are having. So after learning human and computer interaction, we will learn in the next second unit. Here we are more focusing on understanding various types of software. What are the softwares that are helping the computer to work on, and the definition of the operating systems, what kind of operating systems are they, and operating systems, what they are. What is an operating system? I have told you we have hard disk, hardware. Hardware means the mouse, keyboard, or display, screen, or printer, audio outputs, or you can say webcams. All these things are there. They're all into one laptop. Let me put. Though they're all there, there is certain thing which is connecting all these things. For example, your blood is one which connects every part of the body. Correct? If blood does not flow, 1 second, heart doesn't beat, it will stop. It's just like that, right? So software is the heart of your hardware. As long as your heart beats, your body will function. Skeleton is there, organs are there, or other things are there, but they don't work unless and until heart pumps the blood, right? So software is the heart of the heart. So that is the heart. So here what we, just a second. I'm just so sorry. So without the software, your hardware is just like a skeleton. It doesn't work at all. There is no heart means it doesn't work at all. So here, what is the software that is making you work? It is nothing but your operating system, Windows operating system, or Linux or Unix. All these things are called operating systems. Without operating system, this is the one which connects each and every part of the hardware, as well as your CPU, output devices, memory, hard disk, everything. It is the one which is connecting. Then we have what are the examples of the software. It is based on the usage, based on the platform, based on the common applications. Softwares are not only the operating systems. Software is your Java, software is your Power BI, software is the Tableau, software is C++, software is several things, big data, so many things are there. So all these things based on the usage, based on the platform, how we want to apply them, and the general common applications. So let's see. Now, software of computer. So what is software? What is the application part of it? Suppose if I want to know for the system to function, how is the system, what are the system controls, etc. If I want to see, I have one particular software. If I want to have the application part of it, I have one particular software. Suppose, for example, you have for system software, what kind of controls, what kind of internal operations that has to happen, the motherboard, Intel or other capacitors, etc., etc. So here the operating system, device drivers, and utilities. If you see the device drivers, suppose I want to connect it to the printer, right? Printer is the hardware and my system is there, printer is there, but there needs to be a driver that has to be installed into your system so that your printer, you can connect to your printer and get the printouts. If I have a webcam, so I should have the webcam software in my laptop or my system so that webcam will function and then give you the video output. Suppose you want the systems, audio systems, Bluetooth systems, Wi-Fi systems, all these are nothing but the software drivers, which are already, some of them are already installed. Sometimes if we are connecting the external devices, we have to install those drivers so that they will function properly. We get the needed output from the devices. Then developing softwares. So here there are, suppose Microsoft keep developing the softwares. What kind of software Microsoft develops? Of course, there is application part of it is a completely different. For the laptops, for the computers to work, that also Microsoft develops. So, for example, simple thing is the Intel Core processor, motherboard processors that are there. That is nothing but the software that is generated, or the programming languages that are generated, or translators, loader, linker. All these are nothing but the softwares which are used by the systems to function, right? Then we have the application softwares. They carry out necessary operations for specified function. Suppose I want to have the word count. I want to use the Excel spreadsheet. I want to send a mail. So these are all nothing but the generic softwares what we want. So word processor, presentation, spreadsheet, or image editor, video conferences. All these are nothing but the generic softwares what people, as common people, we use them. Then specific purpose softwares. So in specific purpose software, suppose for example, if you go to the airline ticketing, or you want the banking system, in the bank or the other things, they don't use any other things in their systems. They use only whatever be the transaction. Suppose I want to transfer some 20,000 to Mr. Ravi Kumar. So if I want to transfer 20,000 to Ravi Kumar, I go to GPay and then I open my account and then send this amount to Mr. Ravi Kumar. Then it asks me, are you sure you want to send to this number only? Yes. If I say yes, then immediately it will ask me the OTP. It asks me, for example, if I go to the ATM, then it asks me the OTP. If I directly do the transaction, it will ask me the PIN to be entered. If I want to do through some other resource, then it will ask me, are you the same person who is operating it? 2-3 times if you go wrong, definitely it will check that you are not the right person. So this means banking system works. It checks even how much amount is there in my account. I want to transfer 20,000, but in my account only 10,000 is there. Then it checks back in that also. Everything will be checked. Same thing in the reservation systems. You are sitting at home at night, 10 o'clock or 12 o'clock, you want to go from Hyderabad to Delhi, and then you want to book for a flight ticket or a train ticket or anything. So reservation systems, when you are doing, even you can book your TV, movies, theaters, which seat, where, how, which line, everything you can check with the purpose with what you are logging in. So specific purpose software, that these softwares work only for that specific purposes only. That's what I mean to say. Suppose, for example, reservation systems, billing systems, report card generator, or anything. Your electricity bills comes. That is one simple type of software that is generated, so that it comes, reads the things, previous recording minus present recording minus previous recording, it will generate automatically the bill and then go. You cannot say that no, it's wrong, that meter is not working properly. No, all those are auto-generated ones. Now we have, based on the platform, what kind of platform we are working in, so that we can have that kind of software applications. We have, suppose, for example, desktop applications. There are certain things which work on the desktop applications, mobile applications, or web applications. Desktop applications means whatever. See, Zoom is a desktop application, or Microsoft Office is a desktop application. You have Tableau is a desktop applications, or you can say Java is a desktop application. So backend, whatever is working, the MS Access, database systems, database management systems, all these are working on the desktops also. So desktop operating systems are softwares are nothing but Mac, Windows, Linux. All these are the operating systems that are on the desktops. In the mobile applications, you have your Android, iOS, BlackBerry. All these are the operating systems that are there for the mobile applications. Backend based on Android, iOS, whatever. If your operating system is iOS, then you cannot do Android applications on iOS, or whatever is on the iOS, Android, you cannot work on the iOS systems. For example, for the final year BBA, they have the mobile commerce papers, in which you people will be learning. E-commerce is also one paper where you can learn all these applications part of it. Then we have the web-based applications. Plenty of the things work only when you are logging into the network, and then you can access it. Suppose, for example, web-based is nothing but if you can log in through Wi-Fi or this thing, then only your Facebook opens that way, your WhatsApp opens. If you don't have the connections, then they don't work. So web-based applications which run on the browsers, such as cloud-based standalone applications. So these are all the ones what we have. Then comes common types of software applications that can be categorized into 4 types. One is the productivity software. In the productivity software, we have, I don't go into in detail of these things. Quickly, I'll just explain you. In the next class, tomorrow's class, we'll do it. So word processing, you have MS Word, how many words are there, how many letters are there, how many word count, how many pages, what kind of information is there. Everything is given in the word processing. Create business and personal documents such as letters, reports, memos, etc. Then spreadsheets. If in the Excel spreadsheets, you can use immense amount of data, large quantities of data, and you can process it, analyze it, and visualize it. Do anything, whatever you like. You can do n number of calculations based on the applications. You have even Tally, you have even other aspects. So create worksheets that perform calculations on financial and statistical data. Then you have email softwares. Email software is nothing but send or receive email. Today, the promotions have come on emails. Most of the, once you give your mail address to the people, immediately you start getting the n number of mails on your mail ID. These are all promotions for marketing and e-commerce businesses. Email is the best marketing platform. Then basic database software. Here in the basic database software, we have store and manage the structured data. Whatever data your video, your photos, your images, your documents, all those things is stored somewhere on your system. So basic database software, and how do you access that software? All those things will be with the basic database software. Your MS Access Windows, FileMaker, Macs and Windows, LibreOffice, Linux we call. Then PDF viewers, here I have created a document, but the alignment will go off. So what I do, I convert into PDF so that PDF will become very easy for everybody to access it, use it, and my document does not get disturbed. Disturbed means alignment and all does not go improper. So that is PDF creators. Then presentation software. This PPTs and all are the presentation software. Through graphical slides and all, we can work on that. I can publish the online. I can publish the documents or videos, or documents or images, whatever I created. All those things I can do on the desktop. Desktop publication softwares. Then personal information manager. You have the calendars, tasks, notes. G-Notes is there. I'm attending a seminar. Now, today we are attending the seminar. Now, this seminar, we are just listening it. But suppose if you want to note down the content, whatever is the speaker speaking, all those things you can note down in the G-Notes. So that is one kind of software. You can take the recording of it. Audio, video recordings are there. So all these things are nothing but your personal information managers. Then remote desktop software, and the access the desktop from wherever you are there, you can just access your desktops. Then we have, one second, I will make it small. Yeah, collaborative softwares. So in the collaborative softwares, application type is the online workspace. This provides online environment for running cloud-based services applications. So collaborative means my system is there, but I need to access your Google Docs. Unless you log into Google, and you cannot access the Google Doc. Unless you log into this thing, you cannot apply that. So that is collaborative. Through Wi-Fi, you can connect it, and then through your mail, you can open your Google Docs and all. So Microsoft SharePoint, that environments include file libraries and messaging, Office online applications, Office 365 and all. Then document storage and sharing. You provide private shareable file storage via cloud-based devices. Today Google gives you 15 GB free space, cloud space. You can access that if you want, or you can have the Google Drive or Microsoft OneDrive. So you can store your data. Maybe those are the videos or the audios or the documents or text files, whatever you want to store in that drive, you can store it. And this storage is not on your system. It is on the cloud. Are you getting me? So here it is a collaborative one. Google is one application, the software is there, and you have your system which you are generating the data. So this data will get stored into the cloud in the Google Drive. Then screen sharing. Now what I'm doing is the screen sharing. So you can access whatever I am showing. I want to tell you whatever I want to give you the information, all that information you can access and then see that information. Then video conferencing software. Of course, we are doing the same thing, video conferencing. So this video conferencing platform, prior to COVID, it was not that much used. Of course, that was used only for high-end companies where the CEO or somebody want to address the other people of their employees, they want to address. Those places it was used, but Zoom has made everyone to use for the common man. So video conferencing, video calls, or receiving and sending, all those things became very easy. Screen sharing, then file sharing applications, etc. Then instant messaging software, your WhatsApp and the other things, Yahoo Messenger, all those things are nothing but instant messaging software. And email software, of course, receive and send the emails. Then utility softwares. So plenty of times we have the anti-malware. That is a software. So, but this is protecting you, keeping a firewall around your desktop, around your system. So it protects you from all the kinds of malwares that can enter from any of this thing. It will immediately tell you, be alert. this particular document or this particular file has virus. If you want to open, as per your request, we'll open it. Otherwise, we will not. So like that, this anti-malware will check on the scan. It scans, literally scans means scan. So it scans each and everything and then gives you the alerts. So viruses, worms, and the exploits. Then we will be learning all of them in the 12th unit. Then software firewalls. Of course, we have the software firewalls. That's what I'm telling. McAfee and all will be there. Then diagnostic and maintenance. Sometimes it tells how much you need to use it. Your GB is getting over, your RAM space is not proper, or it gives you the alerts. It checks the disks or error checking, optimize the drives of the Windows, any updates that comes into the system. Suppose, for example, I'm using Microsoft. Let me tell that it is some 2009. Very, very old version. So any new software, when it comes into the market, it tells, do you want to update your system? Suppose my laptop, if I'm using Windows 7, then it keeps giving me the alert. All your new software is not compatible to use with the latest softwares. So I have to use the Zoom platform, then I should have the latest software on my system. So all this informations will be given to you through diagnostic and maintenance software. It checks what is there already, how much is the capability of that, how much more is required for it to access the new softwares. Then compression software, we have the WinZip. All of you know, if I have 10 files and I want to send it to Mr. Ravi Kumar, so how do I send it? Not easy, 10 files to send, and files are very huge. So I can compress them, put into a zip folder, and then forward it to him. Suppose this PPT. So I can put it into the zip folder and then send it to you. All 12 units at one go, it will go. And you can open all 12 units, not as one document. If I send it 300 pages as one document, you feel bored to see. Suppose you want to see the 12th chapter, you want to learn 12th chapter, you have to go through all 300 pages and then start. Instead, if I put unit 1, unit 2, unit 3 into different folders and then send you as a zip file, you can open and go directly to 12th unit and then start learning it. This is how the compression softwares work. Then special software, we call computer aided design, CAD. Most of the manufacturing units use CAD technologies. I think some of you might be working there and you might have learned CAD. Then graphic design, medical, scientific, financial, each one works on a different platforms, and based on the purpose, that kind of softwares are there. For example, if you want to have a graphic design, clarity Photoshop or Canva, all those things are for the graphic design. Then lab for science, difficult one, but that's really gives you more mathematical, fast mathematical outcomes that it can work. Then you have financial, you have more, not only these things, more are there. We can TurboTax or Peachtree accounting or QuickBooks or Zoho books, etc., etc. Then the Slims Word gaming. All of you know gaming anyway. So many gaming softwares are there. Candy Crush is also there. Most of you might have played about it. And textures, Sophie, and iPhones, etc. So I stop here for us. Slide number 9. And I'll stop here so that I can take the questions. 1 second. I can unmute. Yeah, if you have any questions, don't rush and then ask at a time. Please raise your hands and then ask me the questions so that I can clear them. If you have the question, I hope all of you have understood. Anything, I will send you the PPT through this thing. So if you have any doubts in the PPT, you can get them clarified tomorrow also. No problem.
Madam, good evening,
yeah,
madam.
Bhavani. Yeah,
Thank
say.
you, ma'am. Thank you,
One at a time, please.
Thank
yeah.
you.
Aditya, you can speak.
Thank you, ma'am.
Madam, previous question papers, where we can find, madam?
I can let you know tomorrow.
Okay, ma'am.
Yeah, I'll let you know tomorrow where do we
Ma'am,
get
if you
the
have
previous
PDF
question
files, you
papers
can
in.
send us.
PDF files, unit wise, I'll make it and send it.
Ma'am,
Okay,
can you
ma'am.
please
Thank you.
share this PPT with us?
Definitely, dear. I can.
Okay,
Ma'am, do we have assignments, ma'am?
Assignments are there.
Records also there, ma'am.
Madam, good evening, madam.
Yes.
Madam, records will come directly to the Ambedkar, our center, or come directly from Ambedkar University, madam?
I need to get that information. I'll talk and then get back.
Ma'am,
Records
when
Ma'am,
about
and
the
you got any information about
computer labs, when will start, ma'am?
that's what I'm telling. Computer lab, record work, assignments, all these three concepts. I'll give you the information tomorrow.
Okay,
ma'am,
ma'am.
we didn't got any